Let's now answer this past exam question. It's taken from VCAA 2008, paper 1, question 4. It says matrix A is a 1 by 3 matrix. Matrix B is a 3 by 1 matrix. Which one of the following matrix expressions involving A and B is defined? So in other words, which of these actually work? All right, let's now consider one by one. So here I've got A plus 1/3 times B. Okay, let's just for a moment consider what this means, 1/3 times B. Well, I know that B is a 3 by 1 matrix. And all I'm doing to it is I'm multiplying that entire matrix by 1/3. So let's just look at an example over here. And again, in an exam situation, you of course would be working a lot quicker than this, but we're just taking our time to make sure that we're understanding what's going on. Let's come over here. So as you can see, I've just given an example of what maybe 1/3 B could look like. So as you can see, I've got my B matrix here. It is a 3 by 1 matrix, 3 rows, 1 column, and I'm just timesing the entire thing by 1/3 here. When I hit enter, do you see what's happened is I've simply times each of my elements by 1/3. So 30 times 1/3 is 10. 45 times 1/3 is 15. And 60 times 1/3 is 20. But do you see how the order remains unchanged? The order is still a 3 by 1 matrix. And that's really the important part that I really want to stress here. So now, when we ask ourselves the question as, does this work? It isn't going to work because we know that if we're going to add matrices together, they have to be the same order, and these aren't. So let's write in why this doesn't work. That's an ugly, ugly arrow. Let's try that again. This isn't going to work because must be same to add. Must be same order to add. So you can't add matrices of a different order, and these are of different orders. One's 1 by 3 and the other's 3 by 1. Let's now go to B. So as you can see, we're again timesing matrices, but we know that isn't going to affect the order, right? So B is still a 3 by 1 matrix. So let's just write this in. B is still going to be a 3 by 1. This times 2 just means all the elements are going to be doubled. And then we're going to multiply it by 3A. And again, this 3 isn't going to change the order of A. It just means all the elements within A are going to be multiplied by 3. Now, A is a 1 by 3 matrix, 1 by 3. Now, can these two things be multiplied together? They absolutely can, because as you can see, the columns in the first is equal to the rows of the second. So this works, people. B is going to be my answer. That works. It is going to be defined because that holds true. Can you hear the garbage truck outside my house? It is very loud. All right, let's now go to the next one. We've got A squared B. All right, now we're going to think for a moment. Let's look at this for a second. We've got A squared. All right, well, A is not a square matrix. Okay, and we know it has to be a square matrix in order to use a power. So this isn't going to work because A is not a square matrix, but we're raising it to a power. So let's write this in. Must be a square matrix to do a power. So because this isn't a square matrix, it isn't going to work. Same to over here. We're raising it to a number, right? So this is a power. It's not going to work because B is not a square matrix. It's 3 by 1. So we're going to write the same thing. Must be a square matrix to do a power. All right, perfect. We now are going to the next one. Here we've got B minus A. Again, this isn't going to work for the same reason A didn't work. We're going to say must be same order to subtract. And that's it. We're all done. That's how it works. B is going to be my answer there. Hopefully you can follow through the logic of each of those, and I'll see you later.